Right, so recall, what is meant by a vector? A vector is a mathematical object that has both magnitude and direction. Simply put, it has a size and it must be going a particular way as well. We can represent these as lines with arrows on. We can also represent these as column vectors. So a number on the top and a number on the bottom, and that tells you how far left, right you need to go, how far up and down you need to go. There are lots of examples, but the example we've covered mainly so far is simply to describe a movement. When you do a movement, you have to go a particular amount, so it has size, magnitude, and it is in a particular direction. We're now going to make this a bit more general. And I need to introduce some more notation. So let's imagine this is a map. We're going to highly simplify the maps to begin with, but let's imagine this is a map and there's some towns on the map. There's town B, maybe that's Beaksbourne, maybe that's Edinburgh, and so on. So there's various towns on the map. Now you remember from last time that when you want to describe movements, you can then give them a name. So the name is normally in little letters and underlined, and here we're told that the movement that you do to get from O to A, so from Oxford to Aberdeen, for example, is called little a. I'm going to add that to the diagram. So little a is a jump. It looks like straight upwards, really, doesn't it, on this particular map? And a little b, the name for that particular movement, goes from O to B. So this direction here, sort of up and to the right, is called B. This was once explained to me really, really well by a colleague that said, imagine you're playing a computer game that only has two buttons, an A button and a B button. And when you bash the A button, what happens is your character moves up exactly that amount. So, sorry, I'm casting a shadow. When you press the A button, if you started at O and you press the A button, you'd end up at A. If you were starting at D and you press the A button, you'd end up at B. So pressing the A button makes you go straight upwards in this case. In different questions and on different maps, the vector A might not mean straight up. The vector A might mean down and to the right a bit. It sort of depends on the question. But in this question, it looks like vector that we're calling lowercase a is straight upwards. So similarly, a jump from here to here would be a little a, pressing A once. And in the same way, if you press the button B, then you go sort of from here to here, or from here to here. It's a jump sort of up and to the right. Okay, so that's how we can move around the grid. Now suppose I want to describe some other journeys from one place to another place in terms of, well, what would I need to press? It seems like a very strange game, but hopefully you'll see what I mean as we go along. So suppose I want to go from O to C. I'd like to start at Oxford and end up at Cardiff, let's say. That's definitely not what a map looks like, because Cardiff is definitely to the west of Oxford. But let's just go with it for the moment. I want to go from O to C. If I want to do that, then what buttons would I need to press? Now, it's important to realise it doesn't matter what order or what route you take. So you could do all of the A's first. I could go A, B, 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 also known as 2A plus 3B. That would work fine. You could do a B, and then an A, a B, and then an A, and then another B again. But if you think about it, however you get there, I mean, you could even do a B minus A, 2 more B's, and then add 3 A's. That would get you there. But if you added all those things up, you combine them, you would just end up with 3 jumps of B and 2 jumps of A. And that could be written the other way around, of course. You could have this as 2A plus 3B if you want. So 2A, 3B will get you from O to C, and it does not matter what route you use to get there. It's not important what route you use. Let's work out the others. Let's go from O to D. So OD, that's going a B and then down a bit. Well, that's the wrong way along the A direction. So that's minus A. Okay, and let's get to E. To get from O to E, I need to go, should we do the B's first? Does that make sense to you? So we go a B, another B, and then that's only half an A. It's the right way, it's upwards, so it's in the direction of A. It's not down, the minus A, but it's only half of an A. So 2B plus an A. So plus half an a, sorry. I can put that the other way around. I could say this is half an a first. There's nothing stopping me doing a jump of half an a. It goes off the grid, but that doesn't matter. It's just moving around. The grid is not really there. The places are there, and the vectors are defined, but the grid is just sort of to help us. So I could do the half a first, and then I could do my 2b's. That would work. Okay, so the game really is, can you turn things with capital letters into things with lowercase letters? Can you express vectors which are described with arrows over the top into vectors which are described with lowercase letters and underlines? It is important that you know how to switch between them, and that you can find relationships between them. You might need to do this the other way around, so I might tell you, for example, that to get to the point F, you have to do a plus b. Therefore, where is F? And you put F on the diagram. So in that case, if I did a plus b, if I did an a and then I did a b, I'd end up here. And note that the root's not important. If I did the b first and then the a, b first, and I'll still end up there, so I could label that as F. You'd have to go both ways round. There's some important things to note then. I could say things like, this would be a true statement, I could say that BF is the same as DB. As far as the journeys are concerned, that's exactly the same vector movement, it's the same jump. Now, of course, doing DB and doing BF are different journeys. Going from Dover to Boston and going from Boston to Folkestone, they are different journeys. But as far as this map is concerned, they're both going like north one jump, aren't they? So it's completely true to say that these journeys, these jumps, these movements are identical. I could say that these vectors are equal. Two vectors are equal if they have the same size, magnitude, and the same direction. Okay, so it's an odd game. Throughout, what you're really trying to do is express journeys which are currently described with capital letters into journeys which are described with lowercase letters. Best of luck with these then. And one more hugely important thing I forgot to say, when you write vectors described with two capital letters and an arrow, the arrow always points to the right. So you might think that the two I've written here are the same. It might look like this one and this one are saying the same thing. It's just you never write the bottom one. Okay, so the arrow always points to the right.